Okay, so here's another integral to solve. And luckily this one has a factored denominator, so we don't have to factor a cubic to get that. So that's kind of nice. We don't have to do that. So now it's just a matter of, again, we're going to take this this rational function. So we have 41 minus 4x all over, so x plus 2 times x minus 5 squared, and then we have to set that equal to what we want to decompose it into. All right, so in this case we have a repeated linear factor, right? So this is what we mean by repeated linear factor, because I could actually write this as x minus 5 times x minus 5, right? That's x minus 5 squared. So so that's a repeated linear factor. And if you go back and look at that table, well, I guess the first linear factor is distinct, so we're going to write that as a over x plus 2. But the second linear factor, this repeated linear factor, we need to break that up into b over x minus 5 plus c over x minus 5 squared. Right, so we need both of those. We need both the x minus 5 and the x minus 5 squared, because we could have both of those, and they would still combine into this same denominator. All right, so but we're gonna now from here we're just gonna do it the same way. We're gonna clear the denominators. All right, so I'll get 41 minus 4x is equal to, so remember I'm multiplying everything by x plus 2 times x minus 5 squared. All right, so when I do that, then I will end up with a times x minus 5 squared, because the x plus 2's will cancel. And then I'll have b times x plus 2 times x minus 5, because one of the x minus 5 factors will cancel. And then for the last term, I'll have c times x plus 2. Okay, and the x minus 5 squared terms will cancel. So 2. All right. All right, so now we got to choose some convenient values. And it looks like I'm just going to start with x equals minus 2. If I want to solve for a, that'll cause the second two terms to go away. So I'll end up with 41 minus 4 times minus 2 is equal to a, and then I'm going to end up with minus 2 minus 5 squared. All right, so that's basically minus 7 squared, which is positive 49. And you can see over here I have 41 minus 4 times minus 2, so that's basically 41 plus 8, which is 49. So both of these are 49. And so I'll end up with a equals 1. All right, got a. Now we have to move on. Now let's try, let's just do x equals 5, right? So when I do that, I'll get 41 minus 4 times 5, so that's 21. And then the first term will go away, the second term will go away, and I'll be left with c times 5 plus 2. All right, so we have 21 equals 7c. So that tells me that c is equal to 3. All right, now we still need b, but there's really nothing else I can choose that will make a and c go away, but not b, right? Because I chose minus 2, you know, that made b and c go away. I chose positive 5, that made a and b go away. But I can still choose a convenient value, right? And an easy one would be 0, right? And if I put that in, I end up with 41 equals So I'm going to end with minus 5 squared, so that'll be 25a plus, I'm going to have 2 times the minus 5, so I'm going to end up with minus 10b, and then this will be 2c. Okay. Now, but I already know a and c, so that's convenient. So then I will just end up with 41 is equal to basically, so 25 times 1 plus 2 times 3, right? So I get 31 minus 10b. All right, and then I can subtract 31 from both sides. I'll end up with 10. Divide by minus 10, so that means b equals minus 1. All right, there we go. I got it all. Got them all. So let me scroll down. We've got a little bit of room here to finish this problem out. So we've got the integral of 1 over x plus 2 minus, okay, b was minus 1, so that means minus 1 over x minus 5, right? And then plus 3 over x minus 5 squared. Okay, dx. All right, well, the first two terms are easy to integrate. So I'm going to end up with a natural log of x plus 2 minus the natural log of x minus 5. And then I have to integrate this 3 over x minus 5 squared. Okay, so probably the easiest thing to do would be to do a substitution. So I'm just going to do this off to the side. And so I've got 3 integral of, I'm going to rewrite this as x minus 5 to the minus 2 dx. All right. Now, well, actually, so this is essentially like x to the minus 2. I could do a substitution, but it's actually easier just to write this as 3 times the coefficient plus 1, right? So I'm going to have x minus 5 to the minus 1 over minus 1. So that just becomes minus 3 over x minus 5 plus c when I integrate that. All right, so I'm just going to write that as minus 3 over x minus 5 plus c. All right, and that's it. That's my final answer there. And I will join you for the next video.